Thanks. So the domination fractal is a model that I found to be super useful. It is, yeah, as the title suggests, it's about physics, game theory. It has to do with complexity and all the nice stuff we are talking here in the conference. And my main motivation is the following. We know there's plenty of different phenomena that we associate with stuff such as capitalism. But the problem is we can't point the finger on exactly what is like the building block, what is the generator function that is capitalism, right? Some people would say it's property, private property. One would say it's like natural evolution, it's like competition, whatever. And 2 years ago, I wrote a book, a German book, about like my own approach to sociology. And after that, I found the model. So the model Domination Fractal. And I asked myself the question, if I would interpret society as some kind of data structure, as some kind of software, what would be the problem that is solved by capitalism? And yeah, so I'm going to use a lot of metaphors from like AI research, cognitive science, and so on. And we all know that there is stuff that goes like this. If everyone would behave in a certain way, we would have no problems with X. Or I would like to do X, but I have to pay rent, right? So I think it is always a good idea not to think about like what could agents like do if they would want, but more what is even possible, because stuff that is not possible we cannot observe, right? And I think we need to find a model that explains observations that are in contradiction to the story we tell ourselves about what we want to do. Because we know for a fact we want to care about soil, we want to care about children, about society, about neighbors, about ourselves. We want to do this, what? But somehow, in the sum of our parts, we are not doing it enough, right? And yeah, the question is, how can it be that we are the bad guys if we tell ourselves that we are not the bad guys, right? And so let me start with the fractal motivation. Just assume you have a triangle and you take each line, divide it in 3 parts, cut out the middle one and place a new triangle on top of it. And basically the green part is what you actually remove. Then you repeat this process and in the end you get something like this. It's called a Koch curve, right? This is the iteration step you need. And the funny thing about this is that the circumference of this is infinite, right? Because it gets always a third on top. But the area is finite. So this is stuff that happens a lot if you have perfect mathematical fractals. But another thing that fractals also always have is self-similarity, right? You zoom in and it has exactly the same shape. You cannot never know at which scale you are observing a mathematical fractal. And in physical reality, they are bound by, of course, some kind of resolution, coarse grain, Planck scale, whatever. But they are observable fractals in physical reality and they behave after certain power law structures. And I think we as society, we have an underlying structure. It is a fractal, it is self-similar, it has power law going on, and I think it contradicts to what we actually say when we perform actions as society. And I would even say there is no coherent will yet formed in what we would call society. And for this, let us define society. I suggest that we define it as not as the number of nodes that are, for example, humans in this. Let's say, okay, each point here is a dot, is some kind of human or even a firm, a corporation, a nation state. But what I think is more important is the interactions between these nodes. Let us define the society as the set of all interactions between nodes, right? And this means basically information, right? Information transfer. And let's take a look at 2 nodes. What can they do? We think there is a lot of interaction going on. So let's get even simpler and just start to take a look at one single node. One node is a thermodynamic open system, right? It has input, information, neck entropy, like food, right? We would call it energy reservoir, but I think neck entropy is more specific for this talk here. And we have output. Usually we perform work at the physical reality outside of our system, and we also put out information, right? So, and while we are doing this, we increase the entropy of the system, right? Of the universe, basically. And to make this, because this is very complicated, and I also wrote it in a paper, what is going on in the input-out relations of one node, let us assume we are a little bit more easy. Imagine water reservoir, and you know exactly you have a lever, you pull it, and then the water flows downhill. You know for a fact that you have kinetic energy in the water that goes down, and you know you can actually go there and take a little bit of the kinetic energy and transform it to another energy form, for example electricity, right? So you can just pull out a little bit of it and use it. And I think this is an important metaphor we need here in order to construct what I call the domination fractal. Because we as nodes, so the small blue one, we are some kind of node, right? I already told you we get input and output, we perform work. And I think if we think of this as some kind of data structure, we say, okay, we have a decision space, right? We have physical properties, we can move our arms, our limbs, we can speak. So we have a decision space. And this, to me, as a physicist, links us to entropy, because entropy usually is defined as the logarithm of a number. And the number is actually the number of possible microstates given a macrostate by some kind of observable, measurable units, for example, pressure, temperature, and so on, energy. And with this in mind, so let's just keep, we are a node and we have a decision space. I think it is useful to define violence as a process that is reducing a node's decision space, right? So, for example, I have a cage, I pull a human inside, so the human cannot walk anymore away. So this is a restriction. But if I would lie to a human, this could change the decision space of the human as well, right? And a lot of like propaganda, a lot of some other strange things to me look like violence, even though you can obviously, in my definition, be a victim of violence and without even noticing it, right? And I think this is important to understand in order to answer the question I stated earlier. And if we have this, we just define power as a state variable or a state, basically the ability to inflict violence on nodes. And responsibility in this way, as like a social construct, is the identification of a power gradient, right? Think of it for yourself in when you go to society and think about stuff. I think these definitions make total sense, even though they might be confusing in the first place. So let's call exploitation a very special interaction. It is an interaction that always, so first of all, every interaction transfers some kind of information, right? I give you a bottle of water, you give me whatever, some money. And if there is a huge power gradient, I can exploit more out of this interaction, right? I can get more out of it if I have a huge power gradient on you. I think, basically, if I would have a good super theory of society, I think as a special case, economists or economy would be like inside of it, right? So a theory of pricing should basically inside of my theory, and I think prices are indicators of power gradients to me. And also profits are somehow related to neck entropy, I think neck entropy gains, right? And I think, first of all, we have resources that are always, for example, fossil fuels, they are neck entropy storages, but also people are neck entropy sources. Because people are reservoirs for neck entropy themselves. They are open systems and they can behave and they can perform work. So to me, as a physicist, it is both neck entropy, right? The thing is, in society, one-to-one exploitation is often unstable just because there is society interfering, right? Someone tells you, this bottle of water is not cheap. Go get another one. It's better for you, right? And that's why I think it makes sense to think of profit as a measure of control. If I control someone, I can make a lot of profit out of it. If I cannot, then not, right? And I think the extreme value of maximum profit would be someone donates stuff to me and I do not even need to use force. I think the more stable thing for exploitation is an interaction between three nodes. And the three nodes usually construct an intermediate, and the intermediate step, it has like some kind of information asymmetry and it can charge a fee. I think this is the main exploitation topology that we can observe in our society that constructs what I call the domination fractal. And this is the idea, okay? There will be an interaction. And the thing is, the question you only need to answer is, can there be someone that makes a profit of the interaction that will happen anyways, right? There will be interactions. Can you exploit it? This is the question. And I think this is the generator function of the of what we would in the end construct as and say it's capitalism. Okay, so we go back to our society graph and just say, okay, the subset of all interactions that are exploitive are the domination fractal, right? And why is it fractal? Because if I just introduce a new dimension and say, yeah, give it a hive, right? And say, call it power. Let's say power is some kind of access to neck entropy reservoirs, which includes human decision spaces, but also huge levers, for example, let's say a nuclear bomb or fuels, or I have a lot of lumber back in my whatever in my chamber. This is all neck entropy, right? And it enables me to perform work in the physical universe at my will, basically. And I think almost all organizations we are observing in capitalism are structured like this. They have all this pyramid structure. And I think the information flow that goes from bottom to top and top to bottom is always, in a game theoretic sense, some kind of Nash equilibrium, right? It gives you the payoff matrix, and then by the payoff matrix, basically you can say it is contingent what will happen to all these nodes, how they will behave. Right? You can choose between Snickers and Mars, but you cannot choose to get the whole factory to work on your own, right? And I think the only way out of, and this is what we know from game theory, is informal cooperation. It needs to be informal in order to, in order to reduce this problem here. If it is informal, you cannot generalize a fundamental exploitation cell on it. And that's why I think informal cooperation is important here. Right? This is like a horizontal line then. This is an interaction between nodes that have proximity somehow. And they reduce, of course, then like the contingent emergence of exploitation, I think, because there is less power gradients then. So this is the big picture. I don't know why I choose this here, but yeah. So the main idea is we have all these nice words: violence, power, responsibility. I would say culture is another important word, because culture, as you already saw, violence is a pretty broad definition. Basically, if there is a human with me in one room, it is already restricting my decision space because I cannot walk through it, right? So I always have to somehow cope with the fact that we are always in some kind of violent context, right? So I would say all the measures of cope, all the ideas how to communicate with each other, I would subsumize them under culture techniques or something like this, right? And yeah, so the main idea is this. Of course, it is about complexity. It is emergent, right? We know that our networks are emergent. We know there is determined chaos. That we have a problem to predict what happens next. And yeah, I think the paradigm is, can we find what we are actually optimizing if we have this kind of pyramid structures there? What is the cost function that is optimized for? What are the input-output relations? And yeah, we can think of this as, yeah, for me, for my example, I am a physicist. I did a lot of numerical simulations. To me, it is more like cybernetics. For others, it's a system theory. For others, this is control engineering. I don't mind, right? And all this connects to entropy. And this to me is important because, yeah, I'm a physicist and it makes total sense, because the second law of thermodynamics is always like a good a good indicator if your stuff works or not. And I think, oh yeah, I mentioned this already, you can be a victim of violence without even noticing it. And so domination to me is defined now as if we have this control paradigm. Let's say we want to know what happens next. Then you would say to, like, if from a cybernetics perspective, we can somehow enable control in our network. But I think domination is the reward hack for this. I think domination means I will enforce some kind of properties onto my systems in order to make it trivial to know what happens next. I think this is what domination is about. I think we have desired versus measured, right? And we want to optimize a cost function, for example, what happens next. And if we use coercive strategies, if we use narratives that form human decision spaces in order to make them somehow fit into our agenda, then we know what happens next better. And I think, yeah, if we define it like this, then dominance is autopoietic. I think it is stable in the short term, never in the long run. We know this for a fact. Most pyramid structures like this are not stable in time. They usually eat up all the neck entropy until they basically starve out the substrate from which the pyramid is emerging. But it is self-reinforcing and it is also interacting with the environment. So to me, dominance is a principle similar to biological life. It applies work to itself, to the environment, and it's autocatalytic. And by the way, here I use the concrete, I use the source I found from Stuart Kaufman. I think it is a theoretical biologist who wrote a book recently about this. Very interesting. And yeah, so let me come to the end. If I would be able to have my domination fractal, now I give you some kind of observations that motivate this idea is good, right? First of all, we know in neoclassical economists would say we have capital theory, human capital, and it describes how income comes to living, but we know for a fact this is wrong. For example, for example, your education is not correlated with your income. The age you have is not correlated with your income. The firm experience is not correlated with your income. You see all these small numbers, right? 0.09 and stuff. Totally awful. And firm experience also not. Even if you cherry pick and try to find the linear combination that works, you cannot get over 0.27, which is awful. But we know for a fact, in firms that are like hierarchical, the number of nodes below you, if you are in a certain position, increases exponentially with rank. And it's just to be found that the normalized pay in some kind of firms are behaving like this, right? And we can even find more firms, and I will link you the sources for this, that this is the actual correlation, right? The number of people below you is basically a good correlation to what you actually have in terms of income, right? And to me, this is a really good motivator for the domination fractal. So there's another thing, I call it, so it is Kleiber's law. I need to skip this, I think. It's about from biology, and we observe that human gigastructures behave as if they are living beings. But as I said, I have to skip this. There's another more interesting thing, I think. It's what I call Boltzmann-Pareto distribution of income. It means usually, so there's a physicist, I think he's called Viktor Yakovenko. He found out that over all Western societies, we can find an upper point, few percent, which income is Pareto distributed, which means they can invest money to get more money. And everyone else is just human capital. Everyone else is just a node with a decision space, and it is exploited. So these nodes cannot get financial assets. Basically, they can't invest. This is their property, and this is super interesting to me, because this is basically something like, okay, our domination fractal has some kind of small edge in the end where all the control habits are and where all the data streams and the influx is going, right? All the cash flow, for example. And yeah, they found it to work well for a lot of data points, right? And of course, this is contradicting neoclassical theory of economics, but this is esoteric anyways. And another funny thing is to be poor is very expensive. We know all this, right? But I have to skip this. But this is still funny, a funny idea, because in the domination fractal, it makes total sense that all the fees are like propagated downwards, right? The more you are below, the more you are in the downward direction, the more fees you have to pay for everything you do outside. Everything outside in the economic system has to, you have to pay a fee, an additional fee on all prices. And the more you are downward, the more expensive everything becomes, right? Even drinking a coffee or whatever. And I think, to me, capitalism can be interpreted as some kind of gradient descent, like some kind of optimization. Okay, it is. We can identify backpropagation in terms of machine learning as top to bottom by fees, penalties, and incentives. And I think the profit signal is the learning signal. And we are basically constructing a paperclip maximizer here. And I think what we can state is that the accumulation of capital is not the end goal. I think predictability is the end goal. And I think domination is the reward hack for this, which means that the profit signal and capitalism is a surrogate function for this. And in the end, I would say prices are dependent on the power context and production costs. Financial bubbles are closed loops for inside of the fractal that are not connected to some kind of neck entropy reservoir. And for example, I think in my analysis, it says that the UBI, so the UBI is not changing the topology of the fractal, and that's why it would not help, I think. Okay, this is my talk. I hope I made it in time.